What's up guys, today we're going to be taking everything we've learned in the last 3 days and just mashing that all up into one application. So we're going to be projecting our camera to our background and then add the gyroscope in there so we can rotate around a 3D UI and just make sure we build that to mobile. We're just going to do everything that we've done in the last 3 days, but we're going to mash it all in one go. So let's get started right away. So right here I've got a clean Unity project, something that has never been touched before. So we just start from scratch and we're gonna code everything super fast because we already seen how to implement those, the camera and the gyroscope. So we already seen that. We're gonna do everything super fast so we can just get on to integrating the whole thing into one. So right away I'm going to save my scene, call this the game scene without the W if possible. And we're gonna be creating a new script. This one is gonna be called Markless AR. And this one is going to include both the gyroscope and also the camera. So we're going to do everything in one go right here, and we will be doing it super fast. So sorry if you guys want to take your time, but we've already been through that. So right here we've got the gyroscope. Let's declare the float we need, not the float, sorry, the fields we need to have this work. So private gyroscope gyro. We were using a camera container so we can actually rotate an object around the real world. And then we've got the rotation. So private quaternion rotation. Sorry about my typing, I keep changing keyboard every day here, so it's just I have to get used to a new keyboard every day. So those were the only field we needed for the gyroscope. Now let's move on to the camera fields. Private webcam texture. And like I said, I suck at keyboard. Webcam texture, this one is cam. And the next one is going to be a public raw image because we're using Unity UI. That will simply call background, and finally public aspect ratio fit. That we'll just call fit. Now these of course are not included right now, so what we'll do is we'll highlight and then hit Control and dot, so we can include using system unityengine.ui, not system, only unityengine.ui. Alright, and then finally we'll have one more boolean down here that is going to say AR ready. Because it might happen that it's not ready, it might happen that it just doesn't work for that device, and we gotta make sure we don't update if that's the case. Okay, let's jump right into the start. In the start, let's start by doing check if we support both services. We're gonna call them services. So by service, I mean the gyroscope and the camera. We're gonna start with the gyroscope, so gyroscope right here, with a simple check. So if not system info that supports gyroscope. If we do not support the gyroscope, let's simply make sure we don't go any further. So we're gonna open up the brackets right here and say debug.log. This device does not have a gyroscope, or any other message. Really doesn't matter because the end user is never gonna see a debug.log in that case. It's only for us. And then we're gonna say return. So if we go through that check, that means we can actually use the gyroscope. Now let's check the other service. In this case, that's gonna be the back camera because we don't really care about the front camera in this case. In this game, of course, we're not gonna be using a front camera. Now the next step is to iterate through every single camera we have, so every single device we have. We're gonna hit 4 and then do a double tab so it can actually build it up for us. For int I is equal to 0, as long as I is smaller than webcam texture, the actual static class, dot device, dot length, device, dot length, and then we iterate through every single one of them to check if we have a back camera. So if webcam texture dot device at the index I is front facing. So if it is not front facing, remember we've put the exclamation mark right here. If it's not front facing, we're gonna say cam is equal to a new webcam texture and then give it the name. So webcam texture device at the index I dot name, and then let's do screen.width and also screen.name for height, for the other parameters. And we will break out of the for loop if we do have a camera right here. But we're not exactly sure if we have a camera or not because we only did an iteration through a loop. So we need to make sure that there is or there is not a camera. So if we did not find a back camera, let's exit. If cam is equal to null, that means that cam was never was never actually instantiated, was never actually assigned. So in this case, we do not have a camera. Let's just copy over these two calls right here and change gyroscope for back camera. So this code right here is only to check if our services are on. It's not really activating them. It's not really doing anything with them. It's only checking if they're available or not. Now, if we made it that far, that means they are available. So both services are supported. Let's enable them. And let me know, guys, if you actually enjoy me putting comments in the code. It's something I'm going to try and start doing now. So if there's support, let's actually do the gyroscope first, camera container. New game object that we'll call camera container, and then we'll move on by saying camera container dot transform dot position is equal to transform dot position. This way, the new container we just create assumes the position of our camera, and then we can change the parenting order. So we can say the camera is now the children of the camera container. So transform set parent camera container dot transform. But we're not done setting up our gyroscope. If you guys remember, we also gonna be saying gyro is equal to input dot gyro, and also gyro dot enable is now equal to true. So this is all we need in this case for the gyroscope. Now let's move on to the camera. For the camera, it's really simple. We do a cam.play, and we make sure we change the texture of the background. So background.texture is now equal to cam. At this point, we enable both our services. We can say AR ready is equal to true. So that is it right here. That's our very long start function, just to make sure both our services are, well, first supported and then activated. Once we have done our start, let's quickly do the update. This one is a little bit smaller, so private void update. And let's check, is the AR ready? And if it is, we are going to proceed with our calls. Now, in terms of the update here, we only need to do one line for the gyroscope. If you guys remember, the line is really simple. Update gyroscope. Oh, sorry. And the line was something like transform local rotation is equal to gyro.attitude times the rotation. So that's the only line we needed for the gyroscope. However, for the camera, we had to update the camera every single frame because we had different angles, and also because Unity has a weird problem where the communication to the camera device is not always instant, and it takes a little bit of time before the information actually reaches the camera. So we have to update every frame because of that, which is quite a shame, but that's what we're going to be doing here. So let's do update the camera, and we're going to start by calculating the ratio. So float ratio is equal to cam.width divided by float cam.height. And then we are going to set it right away by saying fit aspect ratio is now equal to ratio. Let's move on to the next one. It's the scale in Y, so float scale Y. Then we ask, is the video vertically mirrored? And if it is, let's do -1. And if it's not, we'll do 1. We set that value on our background rect transform. On the local scale, we say new vector 3, and then 1, and then scale Y, and finally 1 again. And finally, for the camera, we also needed the orientation, which is actually a integer. So we'll do cam video rotation angle minus video rotation angle, and then background rect transform local angle, local Euler angles is equal to new vector 3, 0, 0 orientation. And that is it for the code. Actually, we've just nailed down all of the code super quickly. We can now go back to our scene and actually set it up. Now we've got weird setting up to do because we're going to be using 2 camera in this case. And let me explain to you why we're going to be using 2 camera. We're going to be using 2 camera because we are displaying the raw image, and that raw image is going to be considered as a UI piece, and the UI piece is usually rendered on top of everything. We don't really want that. We want to have a background camera. We want to have a camera that is actually shown in the back, and we can have 3D objects in front. So let me actually show you how we go about it. Let's start by actually putting our Markless AR script on top of the main camera. And I'm going to create a new object, a new UI, raw image, that is going to be our background. So that's the background camera. It's not actually a camera, I'm going to rename it simply for background. Let's make sure this one has a aspect ratio filter on it. The aspect ratio is set on envelope parent. And also let's make sure that the background is on stretch, both axes. So we've got something similar to last time. And this is, this is basically the same thing we've had as last time. Now we have to play around with one more camera. So on our main camera, what we're going to do here is make sure that we are rendering depth only. Now talking about depth, let's go on that field right here and change the -1 to 1. Since we're here, let's also fill the values for both our background and our aspect ratio. So I'm going to click on the drop down of canvas, drag and drop background in both of these fields down here. Now this is where it gets a little bit messy. We are going to create a new camera by right clicking in the hierarchy, camera, and let's call this one background camera. We're going to be resetting the position to 0, 0, 0. And now the clear flag is not going to be depth, it's not going to be skybox, it's actually going to be solid color. So we're going to be clearing with a solid color every frame, so we have the same actual effect as we usually do with a normal camera. In terms of culling, let's make sure we click on nothing and then we cull only the UI. So we've got our first camera, our second camera, now we have to play with the actual canvas itself. So we're going to be clicking on the canvas and we're going to be changing the render mode from screen space overlay to screen space camera, so it only renders for one camera. That render camera is going to be the background camera, so make sure you just choose it right here or drag and drop. Now if we hit play, we're going to get that message that there is 2 audio listeners in the scene, which is true, so let's just make sure we delete one of them. I'm going to delete the one on the background camera, and then we can just go back to having no more error messages. And now we finally arrive to the fun part. So the fun part is to create a 3D canvas. Let's actually right click anywhere, create a new UI, canvas, and let's rename it to 3D canvas. And that's going to be your 3D interface you have in the game. So I'll put that on world space, really important you change that to world space, and then the position is actually going to matter in this case. Let me just put mine at the origin right here, and we are also going to be changing the width for something like, in this case let's do 300 by 300, but it's going to depend on what kind of canvas you want, but in my case I'm doing 300 by 300. Also, while creating your 3D canvas, if the actual image here, the background camera image, bothers you, take your camera and move your camera. It's actually going to move the other image as well. So back on the 3D canvas, what we're going to be doing here is I'm going to be creating a simple compass, because that's what people do when they have the gyroscope for some reason. So I'm just going to go ahead and create an image, and we are going to try and make this a compass. I could actually go ahead and Photoshop and try to create something that looks good. However, not everybody might have Photoshop, and we are not really making anything splendid looking. We just want to have something that is working. And never mind the image for now. I'll be creating a panel first, and then I'll be creating images. So here's my panel. I want to have this one rotated on 90 degrees, so it's actually below me. So when I walk, I can look down and have the orientation of the real world. So as always, you want to be resetting the values to 0, 0, 0 when you stretch, and then I'll just be pulling it down just a little bit so we can see what's going on. Also, just to understand what's going on the other actual view, I'll take my game scene and I'll just move it right here. Take my main camera and rotate the main camera 90 degrees on the x-axis so you can actually see it. So now if I play with the panel, as you can tell, this is what you see in the game. Alright, so that panel for now, only for now, I'll be putting it on black and full opacity, but that is only for now. I'll be removing that later on. I just need to have something I can actually look at right now and work on. So right here, this is going to be my compass. Right click, then get a image in here. The color is going to be green because compass are green in my head for some reason. And I'm actually going to make this stretch on the horizontal axis, make sure I put everything back on 0. And then the height might be something like 2. Just a line that crosses the whole screen. So this is horizontal in this case. And sorry, not the whole screen, but the whole panel at least. And let's have another line, but this time for the vertical axis has a width of 2, and the rest is on 0. Okay, this way we have a nice marker. Let's change the name for vertical. And finally, we need to input some text somewhere so we know where is north in this case. So I'll be going under text, create a new UI, and I'll just make sure this one is big enough, so say 30. Turns out my height was not enough for this to display, so here it is. If I just bump my height up, it actually shows. Now, is north really in that direction? I don't really know at the moment. I'll have to tell in the real life. I know where the north is in the real life right now, so I can actually double check with that. And now just to give this a try, we are actually going to build this and have a look on the device itself. So I'm going to plug my device and actually walk around with this. Alright, the phone is connected. I'm going to go under File, Build Settings, make sure I switch to Android. And then I'll have to set my bundle identifier really quick. So click on Player Settings. Then down here, we are going to change this for say, N3K. And let's put that in small letters, N3K, and then I'll just call this AR for now. Build and run, let's call this build. And wait until this is actually pushed to my device. So I'll quickly go on my device and start recording there as well. Alright, so it's running on my device right now, and it asks me if I want to allow access to take pictures and record, and sure, because we're using the camera, of course. And we get the splash screen. After that, this is what we end up with. And right now, I do not see any of the UI, so I'm assuming that we did something wrong. Let's just look around in case it's hiding somewhere in the world. And it doesn't seem to be hiding anywhere, so there's something wrong, and let's just go ahead and fix it. Turns out I forgot some of the most important line when doing the code, so if we just head back inside of the start function, and we go down here where we enable the gyroscope, we have to do camera container dot transform dot rotation is equal to a quaternion dot Euler, and then we are going to send in the value 90, 0, and then 0 again. These angles are so our gyroscope does not actually assume the the floor position. Then after that, we want to say rotation is equal to a new quaternion 0, 0, 1, and then 0 again. This one is for the forward axis because we want it to be pointing forward. Let's quickly build that again so we can see if it does work now. So I simply hit Control and B on my keyboard. It's building to the same device, in this case the Google Pixel, and we will just wait a little bit until it actually shows up. And here we are with the splash screen. As you can tell, we could see the icon for a second. That's the setup right here. Again, running the double keyboards. That is because I can't use the Razer stuff. And if we just look down, there is the gyroscope. And if I rotate around, as you can tell, it always assumes the same axis. So let me just point towards north right now. Here it is, that's north. And it always stays north. What we're going to be doing is actually making sure that we remove that stupid image we've got right here. So let's actually uncheck that image, and it actually looks like that. Now, in my case, because I actually know where I'm positioned in the real world, north is not here. North is actually on the other axis. So I'll be just swapping it like this. So rotation minus 180 and moving it that way. That is my north. Now, when you're developing for this kind of game, you're going to be thinking about one thing in your head. You're going to be thinking that you're like in a VR environment. You're just like in a real box, and if you turn your head around, you're going to be seeing different stuff. So just to give you a better feel of what exactly this is, let's make an object actually pivot around us. So we'll create a new UI object, say another image in this case, and maybe make it another color, so maybe like red. Let's make sure the scaling is not too disgusting too, so we can actually look at it. Let's put the camera back on normal rotation, help us gauge exactly where this is going to be. Say about 250 in front, that could be cool. And do we have any cool image we can put there? Let's just put a circle for now. Hey, this is Japan now. But yeah, this is going to be an image, and I want to make it rotate around you so you have a better feeling of, this is a 3D environment and you can actually put stuff around you. So let's put a rotating or I'll call it orbit image. We are going to create a new script really quickly. I'll just call this one orbit. And make sure it orbits around the main camera. So in the update, I am going to do transform.rotate around. And we'll be using the second overload here, so vector3 point. The point is going to be transform, actually main camera, or sorry, camera.main.transform.position. We want to be rotating on which axis exactly? We want to be rotating on, I think it is the vector3.up. And let's do a speed of, say, 90 degrees. No, actually, let's do 10 degrees every second. So time.delta time here. Really simple script. And I'll actually just run it inside of here before, see if it works or not. And we end up with something like this. So it rotates around the main camera. This way, when the main camera moves, we can actually look at it like this. So, let's build this to the phone and see how it looks like in the real world. So right here we've got the previous build, and in a second I should get the new build because I'm still wired up and I'm still waiting for it to be pushed. So if we just wait a little bit. And here is the new build. I'll quickly unplug this. And as you can tell, north is that way. That's my actual north right there. And if I'm looking in front, we still get some rotation issues that we can actually fix. Where's my cube? Oh, here it is, and it moves as time goes. Now it's gonna hit north real soon. That's north. And if we just move around the place a bit, so this was our little preview right here, and something that I really dislike about the gameplay of this, well, it's not really a game, but something I really do not like about this build is the fact that when I was moving around, I could change my phone rotation. So what we're going to be doing right here is locking it. I'm going to head over to player settings again. And now under resolution and presentation, I'll actually make sure that this is not on auto rotation. Let's put that on portrait. So Pokemon Go puts it on portrait. You're always supposed to be playing in portrait mode, but other games like any like camera application that allows you to take picture, they usually do it on landscape because you can actually take good pictures. In our case, it's really up to you, to be honest. I'll be putting it on portrait because I just like holding my phone like an actual phone. And of course, we're not taking any pictures, so the resolution in that case doesn't really matter. Now, of course, the only thing left to do is to actually build it on your phone again and have the proper build without the auto rotation on it. So that is pretty much all there is to it. From that point, from just having this, you can then put 3D object in the world. So the way Pokemon Go does it, it has like a fixed Pokemon at a certain place in the world. So if you guys remember, we had this circle right here. If it did not rotate, if we did not have the orbit script, it would be at a fixed place in the world. Now, what they do in the Pokemon Go game is they have a Pokeball attached to your camera. So when you rotate around, when you look around, when you orbit around, you can actually always see the ball. However, the Pokemon does not move. It is still in the fixed world. So just to recap, there is a Pokeball attached to the main camera as a children, and there is a Pokemon that just stands there in the 3D canvas or in the 3D world. Something cool you could also do is make sure you plug in the GPS from that, and you could display the coordinates somewhere top left or top right in the screen, or maybe just if you look on top you have the coordinates of the world. There is many things that you could actually do, sunset or down with that. You can do a bunch of things basically. I'm just here to help you integrate it. Hopefully this was helpful to you, and if it did, please leave me a like on the video. Always appreciate that quite a lot. It helps me make more videos like this. And your support has been really great this week, and I'm really happy about that. I just had to throw that right here. Of course, if you want to watch some more videos, there are some more videos right here as always. I'm not quite sure what they're going to be, but they're pretty good, and they're for you. So you should watch them. Alright, cool. Cheers, guys.